Hello everybody, welcome to my YouTube channel. Today in this video we are going to discuss divide and conquer topic. This divide and conquer is a problem solving technique which is used to solve problem by dividing the main problem into sub-problems and then solving those sub-problems individually and merging the solution of those sub-problems to get the solution to our original problem. Basically in this divide and conquer technique, we have to divide the original problem into sub-problem and we have to solve those sub-problems, and in third, and then we have to merge the solutions of sub-problem to get the solution of the original problem. Now let us discuss how the divide and conquer work actually. First step we have to divide the problem, that is break down the original problem into smaller sub-problem. As I said before, first we have to break down the problem into sub-problems, smaller sub-problem. We have to divide the problem until there is no further division possible, and then we have to perform conquer. In this we have to solve the smaller sub problems individually. When we divide the original problem, we will get a sub problem. There we have to solve those sub problem individually so that we will get the solution of this sub problem. When we get the small enough sub problem, that is smaller sub problem, that is referred to as a base case, and there is no further division needed because we have got the smallest enough sub problem and we solve it directly without any further recursion. After we got this small enough sub problem, we have to solve the sub problems independently to find the solution. And in the last step, we have to merge the solutions. After dividing the problem and after solving the sub problem, we have to combine the solution of those sub problem. After combining, we will get the solution to our original problem. Let us understand it more clearly by taking this flow chart. Here what we have done, we have taken a problem of size n, and then we are dividing this problem into two halves, that is left subproblem and right subproblem. We have a problem of size n. If we divide this, we will get the n by 2 size of subproblem. You can see here we have got two subproblem, that is size of n by 2 and n by 2. Here we have performed first step, that is divide, and in the second step we are going to solve these subproblems and find the solution to this subproblem. This is a conquer step, and in the last step we are merging the solution of these subproblem to get the solution to our original problem. This is how the divide and conquer work. Let us understand it by taking an example. Here you can see that I have taken one unsorted array of size 6 and I have divided it into two subproblems, and I have divided it until I got a small enough subproblem, that is this is a base case. And further I have merged the subproblems by sorting it in an order. You can see that I have sorted it in order wise, and finally after doing after merging all the base cases, I have got this sorted array. Let me show you how I have done this. Now here I have taken the same example, the unsorted array. Now we have to divide this unsorted array into two halves, that is subproblems. Let me divide this into two subproblems. If we divide it, we will get these four indexes as one subproblem and these three as one subproblem. We can take these three and these four also as our wish. Now we have to further divide it into another subproblems, smaller subproblems. Since we have four indexes, we can easily divide it into two halves, 70 and 20, and here 30 and 50. Again here we can take these two as one subproblem and this one as one subproblem, or else we can take this one as one subproblem and these two as another subproblem. I'm going to take 60 and 10 as one subproblem and 40 as another. And further I'm going to divide it into 70 and 20. Since we have only two indices, we can easily divide it into two halves. Here 60 and 10. There is no need of, we can't do any division further. So we say these as a base case. Till now we have performed here divide step, and now we are going to perform conquer and merge steps. Now I have to solve these indices into an order. Now we have to compare these two. Which one is smaller? I'm going to arrange it in ascending order, that is smaller to bigger. We can take any order, either ascending or descending, as you wish. I'm going to do ascending here. Since 20 is smaller, it will come first, and 70 is greater, it will go into another index. And now I'm going to compare these two. It is already in order. There is no need to do any sorting. Here we have to do a sorting. Since 10 is smaller, it will come first, and 60 is greater, it will go into another index. We'll take this as it is. And now we have to compare these two sub problems again and merge. Sort and merge we have to do. Now you can see easily that 20 will come in the same index as it is smaller than all other indices, and 30 will come after 20, and 50 and 70. It is very simple, you can see that. And again I'm going to perform sorting on it. Since 10 is smaller than all other indices, it will come first, here 40 and 60. Now we got the solution of both subproblems, and now we have to merge these two subproblems, and we have to arrange it in an order. Now merging. Till now we have performed conquer, and now we are doing merge. If we compare these two solutions here, the smaller one is a 10. 10 is a smaller element, so it will come in a first index, and 20 will come second, 30, 40, 50, 60 and 70. This is our final solution. This is how the divide and conquer works. This is a sorted array. Now let us discuss the analysis of divide and conquer. If we have a problem of size n, we may divide it into two halves, that is n by 2 and n by 2. If the size of n can be divided into any instances of size n by b, this problem of size n can be divided into any instances of size n by b, with a of them need to be solved, where a is greater than 1 and b is greater than 1. Let us assume that the size n is a power of b to simplify our analysis. What I am saying is that let us assume n is a power of b to simplify our analysis. Then we will get this recurrence relation. We will get this recurrence relation for divide and conquer, where f of n is a function which shows the time spent on dividing an instance of size n. F of n is a function which shows the time spent on dividing the problem of size n. Okay, F of n shows the time spent on dividing the problem of size n into subproblem and combining their solution. And this is called the general divide and conquer recurrence. And this is called as the general divide and conquer recurrence. Solution, the growth of solution of its solution depends on value of constant a and b and the order of function f of n. It is also given by one more theorem, that is Master's theorem. Let us discuss that. The efficiency analysis of divide and conquer algorithm is greatly simplified by Master theorem, which defined as if f of n belongs to theta of n to the power d, where d is greater than or equal to 0. In recurrence, t of n is equals to a of t of n by b plus f of n. Then t of n belongs to theta of n to the power d if a is less than b power d, and theta is theta of n to the power d log n if a is equal to b power d, and theta of n log b power a if a is greater than b power d. It will give the same results for 0 and omega notations also. Let us take an example to understand the Master theorem. If we have to produce a recurrence relation for the number of additions, number of additions a of n made by which we have to do it using divide and conquer. The sum consumption algorithm on input size is n equal to 2 to the power k. Then we will get this recurrence relation where a is equals to 2, b is equals to 2 and d is equals to 2. Since here a is greater than b power d, because we know that we have a is equals to 2 and b is equal to 2 and d is 0. Anything power 0 is equals to 1. So a is greater than b power d. Then we will get the recurrence relation as a to the power a of n to n log ba, which is equal to theta of n log base 2 power 2 is equals to theta of n, because here a is greater than b power d, because 2 is greater than 1. So we will get this. So, we can see that in master theorem we have if a is greater than b power d, then we have this formula, right? So I have taken this here, and log base b power a. Here a is equals to 2 and b is equals to 2. b equals to 2 and d is equals to 0, right? So here I have substituted a and b value. If we solve this, we will get the theta of n as our time complexity of this problem. So this is how divide and conquer work. Thank you for watching my video.